Alright, hi. Today's reading. Alright, it's May 2nd, 2017. Reading Chevron overnight 5 FR861 Amtrak General Electric Transportation Evaluation of the B20 Diesel and the General Electric P32 Locomotive. March 20th, June 2011, Chevron Ownerite Company Limited Liability Company, Industrial Engine Oils, Richmond, California, prepared by Van Slyke and D. Anderson. Alright, summary, fuel and oil, piston deposit ratings, engine sludge, line wear, additional inspection cylinders, 5 right, 5 left, piston rings, connection rod bearings, oil performance conclusion. Appendix, fuel inspection piston sludge deposit worksheet, linear piston ring, bearing wear worksheet, used oil data charts and photographs. Alright, summary. Alright, let's read the top. Engine inspection of an Amtrak unit number 500. Summary. After completing 1 year of the operational testing on a B20 biodiesel testing, unit number 500 was brought to the Amtrak facility in Chicago for a detailed inspection of 2 power assemblies. The power assemblies located in position 2R and 2L have been pre-measured prior to the testing installed in the unit number 50. On June 7, 2011, the pre-measured power assembly were removed from the engine for inspection, determining the wear and engine deposit level. The piston deposits and surface sludge ring and liner wear connection rod bearing condition were inspected and evaluated. All performance were video image scope inspection cylinders FR and F 511, 5R and 5 left, and salute of the visual deposits on the tips, and the unknown deposits were affecting fuel flow. The video image scope of the 5 right, 5 left liners showed evidence of rusting and result of past water leaks. In addition, an engine inspection of the oil condition was monitored to analyze the Ornite facility in the Richmond, California during the course of the test. Prior to the start of the testing of the sample, the biofuel B100 and biodiesel fuel B20 was analyzed. Bio100 was analyzed for the glycerin and water oxidative stability. Also, biodiesel samples by B20 were analyzed for the biodiesel content during the course of the test. The results of the test showing that no abnormal conditions is related to the engine deposit of the engine where the condition of the parts were deemed comparable to the normal conditions experienced with the passenger and freight locomotive operations. The engine part inspector showed normal piston deposit liner was minimal with liner wear was minimal with most of the original crosshatch still evident. The piston ring as showed low wear where the surface condition. The engine bearing showed normal wear overlay not worn through, even loading with no evidence for the corrosion. Used oil and fuel analysis showed that oil being in good condition over the course of 1 year. Tested biodiesel content was at B20 level over the 1 year test. Although the locomotive experienced some operational issues during the 16th month test period, February 20th to May 2011, no operational difficulties were experienced due to oil and fuel condition. The test protocol focused on the operational performance of the only one locomotive, the Locomotive Maintenance Officers Association, or LMOA, established the field guidelines specifically for the use of the minimum 4 test 2 reference locomotives. General multiple data points were all effective at addressing the operating issues that sometimes occurred with the individual locomotives during the test period. Definite conclusions commentary regarding the consumption of the B20 diesel fuel and locomotive engines in diverse service applications not scope of this report. Alright, fuel and oil. The fuel used during the testing was low sulfur diesel fuel splash blend of B20 with a transesterified tallow-based biofuel. A sample of the B100 was sent overnight test lab of analysis. Ornite conducted the test method of glycerin water oxidative stability on the B100 B20 sample for the quality. Results showed the B100 B20 and the B20 to be within specification. Sample test fuel B20 were periodically sent to the Ornite test club. The data set show the fuel remained at the 2B20 level over the course of the testing. The test results can be found in Appendix 1. The oil used in the test were commercially available to 20W40 multi-grade Generation 5 locomotive oil. Sample used oil were taken monthly and sent to the Ornite lab for analysis. See the discussion of used oil analysis finding below. All right, piston deposit rings. Two pre-measured power assembly at the cylinder pistons of two left, two right were removed from the test unit. The powers removed and inspected the deposit for the liner, cylinder head assembly, and the pistons. The two pistons were rated using the Coordinating Research Council diesel piston rating method. Table 1 met summaries. The piston deposit from the Amtrak unit number 500. The table below showed the unit number 500 had a moderate piston deposit with a consistent with the other passenger and freight surface. The rating appeared to be alignment inspection result for the locomotive and moderate surface, or the MWH monthly. The operating conditions and the duty cycle for the MWH usage of the number 500 was of it not available at the time of the inspection. The detailed rating sheets can be found in Appendix 2122, and photos can be found in Appendix 5152. Table 1, piston deposit ratings of the CRC, or Coordinated Research Council unweighted determinants. Groove 1, 45.3 and 47.2 on the left. Groove 2, groove number 2, 49.1, second, 2 right, 49.1, 2 left. Groove oil, 0.0, 2R, 2 left. Crowland, 35.72 right, 29.1, 2 left. Land number 2, 14.92 right, 16.3, 2 left. Land number 3, 0.0. Shoulder dermits 145 and 2 right and 142 on the 2 left. Engine sludge. The following areas were rated for sludge: rocker box cover, rocker box valve gear, crankcase cover, crankcase A-frame. The rocker boxes was rated with using the Coordinated Research Council sludge merit grading scale. Sludge ratings were made on the merit scale with the rating of the 10 designates a part completely free of sludge, where the part's increased accumulation of sludge represents a lower rating number. The sludge rating is based on sludge depth and are covered not the color or the character of the deposits. As Table 3 illustrates, the rocker boxes were free of the significant sludge with very little, if any, depth. The table shows the average rating from both the test cylinders. Detailed ratings can be found in Appendix 2.3 and photos can be found in Appendix 5.3, 5.4, and 5.5. The Table 3. Your Coordinated Research Council sludge deposit ratings: crankcase 9.75 and 2R and 2 left. 9.56 rocker case 2R 2L. Crankcase at a frame 9.5. Rocker bar box 9.63. Alright, linear wear. 2R and 2L were visually inspected. They were evaluated at the top and the bottom of the piston stroke, on the thrust, and anti-thrust slides. Linear were observed with any of the wear anomalies that inflicted, including scuffing, polishing, scratching. The liner showed very little wear. No liner showed evidence of scuffing. There was some incipient bore polishing occurring on the top of the ring reversal area. However, the area of polishing was mild. Overall, the liners were good serviceable condition. Detailed ratings can be found in Appendix 3.1. Photos can be found in Appendix 5.6. Alright, a surface finish study was conducted on the liner using the Maher surface finishing measuring device. Surface measurement were taken on the bottom of the liner in the no wear area below piston ring travel, the middle of the liner, and the top of the liner, and the top of the liner. Surface finish measurement were taken with lacquer and varnish material, which the lacquer and varnish material removed with vinegar. Acetic acid table below shows the result of the measurement of the average peak of the value RZ in the micro inches at 0.7 hundredths of an inch transversing length. Alright, the Amtrak Unit 500 average peak of the valley micro inches. Alright, piston zone, top of the lacquer, 118 on TL, 84.5 on T2R. Top without lacquer, 103 on 2L, 138 on 2R. Middle, 135 2L, 97.5 2R. No wear on the bottom, 160 on 2L and 117 on 2R. Additional inspection cylinders, 5R and 5L. The fuel injectors were removed from the cylinder 5R and 5L, but the boroscope inspection was performed on the liner throughout the injector hole. There was evidence of staining, and either from the rust of the corrosion of the liner surfaces. Discussion of shop foreman determined that the locomotive had experienced storage-related failure in past and was most likely to cause the abnormal appearance of the liners. Engine operation used oil analysts indicated that there were no operational difficulties as a result. Inspection injectors showed that there was moderate level of carbonaceous deposits on the injector tips. With 5x magnification, it appeared that the injector type tip spray nozzle were not occluded. However, it was determined that if there was any loss in injector performance interruption with the spray pattern as a result of the deposits, photos of the injector tips are in Appendix 5.7. Alright, piston rings. The piston rings were removed from the piston bolt power assembly, removed from the unit number 500, brought back to the Ornite Richmond facility for inspection. The piston rings were inspected visually for the evidence for the abnormal wear deposits measured with a comparison to the pre-test measurement. The ring faces are examined under magnification and showed only signs of normal wear. There was no evidence of scoring and scuffing. The visual evaluation of the carbon deposits were also made in piston rings. Carbon buildup corresponding to that of the piston weights, medium and light range, were based on the Council Research Committee rating system that measured the data. Visual inspection of the ratings showed in the rings in the normal surface condition. Detailed measurement of the piston rings are in Appendix 3.2 3.3. Photos can be found in Appendix 5.8. Connecting the rod bearings. Connecting the rod bearings from unit number 500 visually inspected where the bearings showed normal wear patterns, even loading where in serviceable condition. Closer inspection and magnification showed signs of hitting metal integration on only bottom of the shell of the bearings. Biodiesel has documented that it caused the bearing corrosion where there is dilution of the oil sum. There is a concern that the pitting may be caused with the corrosive mechanism. The bearing were brought back to the Ornite, were analyzed by the Ornite tribology lab for after visual inspection, bearing the sent to GE for the more detailed examinations on the pitting, determining the cause of the rating of the bearing found in Appendix 8.3.4, and the photos can be found in 5.9. The area of pitting was covered with small cracks and pits. Pits appear to be lined with the cracks. The cracks appear to be enlarged into the pits. Fracture of the edge. The examined pits areas are closed, to be caused by the mechanical rather than chemical action of the corrosion. Further investigation is needed to cause the initial cracking. The photographs below show magnifying image of the cracking pitting of the bearing flash and overlay surface. See the figures below. You have your piston and your cracking. Oil performance. Appendix 4.1 through 4D, 4.1 through 4.8 are plots for use of the oil analysis showing the oil performance during the test. The used oil were collected by the Amtrak personnel were received by the Ornite. Analysis was performed by the Chevron Analytical Labs. The oil was analyzed for vicinity increases by the American Standard Testing Material Method D445, base number BN, ASTM by American Standard Testing Method D4739, acidic number AN by ASTM D664, pentonite insolubles by LMOA, method of ASTM D7317, oxidation by IR, welding metals, American Society Testing Material D5185, fuel dilution ASTM D3524, bio dilution of the Ornite priority methods. These data show the parameters to be within condemning limits. A complete summary of the oil analysis data can be found in Appendix 4.1. Trend of the data implied that the oil was changed approximately 60 days, 270 days, and 400 days. However, the Ornite does not may have maintenance the required records to verify. The plots of 100 degrees Celsius viscosity, Appendix 4.2, showed no significant increase of viscosity up through when the oil was changed. Appendix 4.3, plots, and then AN and BN retention was good, dropping the low of 7.37 millimeters COH over the grams, and AN rose a little over the same time period at 4.8 millimeters of COH over grams before dropping. I'm pretty sure. Alright, calculated pentonite insoluble LMOA method of the plotted Appendix 4.4 method of retraining ran lower the minimum of 2.6 WT percentage. Oxidation of the engine was measured by the DIR method. The graph at Appendix 4.5 shows the oxidation was under control, remained lower the entire duration of the tests. Where metals, iron, copper, lead were measured by using the ICP method, there are 3 levels very low, well within condemning limits. Appendix 4.6 through 4.8 show the wearing metal trends. Fuel dilution. Total the biodiesel dilution were also monitored. The acidic material biodiesel dilution oil may be problematic, being corrosive to metallic surface. The duration of the test must be both fuel dilution and biodiesel dilution was very low, and many observations were below measuring limit. Table below shows the result of the dilutions. Your total biodiesel dilution locomotives. These span from 10-day intervals. You have 0 for dated. Let's skip that. Conclusion. Amtrak number 500 completed 1-year operational field testing using the B20 diesel and a field inspection consuming the evaluation engine of the deposit, where results of the following observation: additional use of oil continuation fuel quality was monitored and analyzed to determine oil performance. Inspection of the 2R and 2L power assembly showed moderate piston deposits, very clean engine surface lacking any sludge deposit depth. Inspection of the TR and TL power assembly showed minimal wear of the cylinder liners and piston rings. Inspection of TR and 2L connecting rod bearings showed normal wear. Evidence of small pitting is not caused by the corrosion, need to be investigated further. Used oil analysis exhibits good viscosity control, base retention, acid control, insoluble control, oxidation control, and used oil analysis exhibited very low wear materials PB, Cu, lead, copper, and iron, indicating low wear. Fuel inspection testing specification result. Fuel glycerin 20 hundredths percent maximum of 11 hundredths. Total glycerin 240 thousandths percentage maximum result 118 thousandths of a percent. Oxidizing stability 3 hours minimum, 41.8 hours result. Carl Fisher water 400 parts per million maximum result, 106 parts per million. Your biodiesel concentration Amtrak's. December 23rd, 2009, 22.4 biodiesel content. February 9th, 2010, 22.2 biodiesel content. February 11th, 2010, 20.1 fuel biodiesel content. April 3rd, 2010, 22.4 diesel content. July 7th, 2010, 23.4 diesel content. July 27th, 2010, 22.2 diesel content. August 9th, 2010, 21.8, and September 13th, 2010, 20.6. February 23rd, 2010, 23.0. January 27th, 2011, 22.22. February 22nd, 2010, 20.0. March 27th, 2011, 20.9. April 26th, 2011, 19.5. May 9th, 2011, 22.22. Appendix 2, position piston sludge deposit worksheet. Appendix 2.1, GE piston deposit measurement cylinder number 2L. Appendix number 2.2, GE piston deposit material cylinder number 2R. Appendix 2.3, GE sludge ratings. The Amtrak B20 testing FR861 Ornite Technology Unit 500 GEP32 SFLD 12 Locomotive Piston Deposit Materials Piston Zone. First quadrant, second quadrant, description of deposit location, total cylinders 2L, top of the groove location. Amtrak B20 586 Ornite GE sludge rating cylinder number 2, local percent and area and depth, Crankcase, Merit 97.5, rocker cover 90.56, crankcase number A 9.5, rock arms 9.63. Local percentage and depth, cylinder number 2 tilt, crankcase cover Merit 9.75, rocker cover 9.56, crankcase A Merit 9.50, rocker arms 9.63. Appendix 3, linear piston ring bearing worksheet, cylinder 3-1, cylinder linear measurement, cylinder number 2R, cylinder GE rating measurement, cylinder number 2R, JA ring measurement number, cylinder 2L, and G connection rod bearings inspection 2, inspection 3-4. Alright, your G in the connection rod inspection top bearing appearance of the even normal loading several condition 50% flash remove or cut on copper showing little light dirt scratching small pitting against flashing overlay. Appearance of even normal loading good surface condition 70% flashing removed overlay removed no copper showings 2% cavitation wear oil gallery small pitting of the flashing overlay. Alright, Appendix 4, used oil data and charts. Appendix 4.1, used oil allowance 4.2, viscosity increase 4.3, base and acid number 4.4, elbow pennant insolubles 4.5, oxidation 4.6, copper 4.7, iron 4.8, lead. It shows the chart, engine velocity, the velocity percentage incorporated, TBTN, TBI, DIR, IC spectral parts per million fuel dilution bio content. Viscosity increase of 100 degrees at CST, days on test. Base acid number, days on test. LMO pennantite, days on test. Oxidization, days on test. Copper, days on test. Iron, days on test. Lead, days on test. Photographs, pistons, thrust, pistons, rockers, rocker covers, crankcase covers, linear injectors, rings, bearings, and top bottom. This is your piston 2R thrust, piston 2L thrust, piston 2RL, piston 2L RBZ number 4, rockers 2R and 2L, rocker cover 2R, 2L. Crankcase cover 2R and 2L. Linear 2R and 2L. Injector 5R and 5L. Rings face 2RL, face 2R, face and backside. Bearing top, bearing bottom. And that completes the reading of Amtrak General Electric Transportation Evaluation B20 Diesel in the General Locomotive P32 locomotives March 2010 to June 2011 Chevron Ornite Company Industrial Engines in Richmond, California.